This problem, we're trying to figure out um, the suspension, right, of the forces going on. However, we know that since there's not a real indicator that there's a force going down or an acceleration going up, right, acceleration up or down, we can assume that the problem, we can assume that the problem is um, the sum of forces will be zero. And since this is not as simple or direct as the other two problems we just worked on, we could assume that this problem has a sum of forces for x and y. Now, to be able to solve for each of these, we have to take into consideration that there's different forces going on. So there's a force going down, which is mg, right, which is just a regular force that's going downwards. And then we have a difference of a force for T3, right? We're going to name it T3, or normal force, however you want to name it, and it's going up in the opposite direction. And since this is a zero, right, the sum of forces was zero, these will equal each other, essentially, right? So it'll be T3 is equal to mg, right? There's an equal amount of forces. The mass isn't just moving down or up. It's staying suspended in the air. So now that we figured out T3 is equal to mg, we could also figure out that we need to know the sum of forces of x and y. Although we know it's going to be zero, to be able to find out if it's true or not, or what's going on, we need to apply the let me see here, T1 and T2, right? T1 and T2, and there's just angles that are occurring here with thetas, right? So we have to plug in these equations for x and y, which are practically similar, although a little bit different, right? We have to apply the forces that are affecting the x vectors and the y vectors. So we can start with x because I believe it's a little easier, right? And the x vectors will have a total sum of force for x will equal to the T2 cosine, right? We're doing cosine because that's how we're doing it, right? It's going to be the cosine when we're looking at the thetas here, right? The right triangles. So cosine theta 2, and we're doing the same thing for the T1 cosine of 1, right? And if we were to rewrite this for both of them, right, eventually we're going to be left with E, which is a sum of forces of x, is equal to T2 cosine theta 2 minus T1 cosine theta 1. Okay, and that should give us 0, right? Because that's what we're looking for. So now since we solved for 1, right, this is the answer for the first part for the sum of forces of fx. Now we need to find the sum of forces of fy, which should also equal 0. Now, it's practically similar to the first one. However, we need to add the fact that mg is another component to the equation, right? It's a negative component that's happening. It's working on the y vectors, right? Because you got to remember that we gotta add in all the sums, right? We got to add all the sums together. So if we do that, it's essentially going to be the same thing. It would be total forces of Fy is mg minus T1 sine of theta 1 minus T2 sine of theta 2, which is all going to equal to 0 as well, because we already suggested that the sum of forces is going to be 0 because m is still suspended in the air. Okay, so perfect. Good job, guys.